Cool. So today we're going to talk about the UV unwrapping and what UVs are all about. And the first thing that I wanted to quickly address is just reverting back to one of the previous classes we had about the different components that a polygon surface is essentially comprised of. Okay, the first one that I'm sure you guys are familiar with at this point is essentially the vertices, okay, or the vertex as a singular. Okay, so if you stack multiple vertices together, then you essentially have the ability to connect them via edges. So this one is going to be an edge. Okay. And then finally we have a face that's essentially covering that part of multiple edges closed up together. Okay, so that's the edge. And then finally that inside there, that's the face. Now there's one additional component type that we haven't addressed in the first class. I think I've maybe barely just mentioned that, but it's not like an official thing that we have addressed as of yet. So what is this fourth type of component type? It's essentially UV. Okay, UVs are essentially the same. Again, I'm going to refer to that little dot over there. This is also considered UV. What does it stand for? It doesn't really stand for something in particular as in like an abbreviation for a word, but it rather stands for the fact that it's, if you were to put something on like a graph, right? I'm sure most of you are familiar with the X and Y concept when you're doing something for, you know, quickly drawing out a graph or something of sorts. So let's say this is unit 5 and this is unit 12. Okay, over here. And where these two essentially meet up, that's essentially where the connection point would be for those particular points, right? So U and V simply refers to, on a grid-based flattened version, where a certain vertex would appear. That's essentially what it means. So if I had to flatten out this box, I would cut it up into parts and I would lay it out flat. Like, let's say we take like a matchbox, just a simple concept of a matchbox. And if you look at a matchbox, you can actually see where it's been glued together and where it's folded over itself. And then where they kind of meet up, that's essentially how it creates a three-dimensional object. So it used to be a flat two-dimensional surface, but then glued together to kind of create the three-dimensional shape. So if you were to do the same thing to a 3D box, we essentially need to decide where we want to cut it and where we want to lay it out in a way that it eventually becomes a completely flat surface. And that flat surface can then be printed on in a traditional environment kind of scenario. In our case, we're essentially laying out a template so where the 3D surface will receive texture space. And then based on that, you can then go and take that template into Photoshop and then actually paint on, you know, your own textures for it. So the challenge for today is essentially just that. We're going to create a box, very simplified box. We're going to talk about the different methods for UV unwrapping this thing, and then we're going to actually paint or write down specific numbers or, you know, arrows or something along these surfaces on the flat 2D, and then when we bring that as a texture back into Maya, we will essentially apply that on top of the surface to then see how that matches accordingly. Okay, so we're taking a three-dimensional object and making it a two-dimensional template. Whereas in a real-world environment, you're starting off with a 2D template and you're cutting it and you're gluing it together to make up the 3D object. If you think about garments, if you take a t-shirt, essentially it has a back panel and a front panel, and then obviously the seam line where the two parts kind of meet, and that's how you kind of create the three-dimensional object. In our case, we're starting off with a three-dimensional object and we need to just flatten it. So UVs refer to the U direction, meaning along the usually the horizontal axes, so going this way and that way, and then V going vertical. I guess that's the most easiest way of remembering, being V going up and down, vertical. Okay, so Y is replaced with V and then X is replaced with U. In other software, they also talk about W as an additional UV coordinate space, and that essentially refers to rotation. It's too much of a complex thing to take it to the more basic elements. It will just think of it as an additional attribute. You can't really, map it. It's just a way of rotating a texture from one direction up and down. So it's either front facing or back facing. That's pretty much it. So yeah, this is essentially component type 1, 2, 3, and then finally 4. Does this make sense? Cool, great stuff. So I'm going to create another little document and quickly write out the steps that we essentially need to take to kind of create a basic texture space for us to paint on. The first part is obviously creating the object. Okay, let's create asset. And that could be literally anything from box to character's face, or whatever, cylinder. In our case, we're going to keep it very simple. Start off with a box. It's easier to map out planar projections than it is to do it on a cylindrical shape. I'll still talk about some of the others, but essentially that's what the book is about. It covers some of those more in-depth asset UV mapping techniques. So this is going to be step 1. Step 2, this is the fun part, right? The creation of the actual asset. The UV part, most people hate UVs. Reason being because it's very technical and it's, a lot of things that you have to think about in terms of seams and how to flatten an object and the understanding of what's most optimized to kind of get the biggest texture resolution and all those kind of things. So the next part would be actually UV mapping it. So UV map. And that covers many different aspects from mapping types, planar. We have cylinder. I'm just going to quickly write out basic ones. There's a sphere one. And there is an automatic AU auto. Right, so I'm just going to write out those 4 key ones. Don't think that when it says auto, it's going to make your life easier. In fact, it makes it even worse. In certain situations, it works great. Other situations, it's pretty crap. Right, so going on from there, once you've laid out the UVs, essentially, or rather mapped out the UVs, think of it as, if you work on a table and you have a table full of contents. So this is my desk, here's my keyboard, here's my screen, and my mouse, right? There goes the little cable. So now I have stacks of paper, and I've got my coffee cup here, and I've got a plate of food there with, I don't know, whatever, and I've got something else, my cell phone lying there. You're getting a space that's quite cluttered, and in terms of actual workspace, it becomes annoying to have to work with a computer, especially if there's so many things in front of you. So what I want to get to is the idea of trying to make my workspace as big as possible so that I can actually move things away from my local environment and just make this infinitely big. Think of this as infinite, going this way and this way. What's it sign for infinite? I think that's what it is. Upside down 8. And so now, having more space to work, I can then just take in one thing and work with that in my environment, and then when I'm done with it, I can move it off to another area and then bring in something else. Okay, so why am I using this concept, or why am I using this idea to explain UV mapping? Essentially, the UV mapping space is an infinite space, but the area that usually gets mapped or projected is the local area that is kind of represented by a little grid like that. And usually when you create a map, like a UV map, it places it right in the center of it. Now, For me, when I'm doing the second projection, it's going to stack that one on top of another one, on top of another one, and becomes very difficult to work with. So what I usually do is I take my first, let's say, projection mapping. Once I'm done with it, and I just move it off, get out of my way. I'm done with you for now. I need to get the rest of the stuff sorted. Once I'm happy with it, I would then take that as all the pieces being UV mapped, put them together, and start going through this process of sewing and moving parts. So that's the next step. So brush, move plus sew, UVs. Let me just do it this way. There we go. So I guess I can clear this out as well. I think that will suffice in explaining the concept. Come on, almost there. Cool. So once you've done the UVs and you've kind of sewed parts that kind of belong together, you would then go and lay out the UVs. So this is layout. You can do this either in a manual way, or you could do it as an automatic kind of approach. So the auto usually does a pretty good job. In certain situations, you want to stack them more precisely. Now, what's this layout? What's this concept? Now, think of it this way. How many of you have ever looked at some of these, how did they make this object kind of videos? There's a lot of them on YouTube, and I think they have it on TV as well, where they actually show you how they create, let's say, other garment panels or leather stitching for chairs or stuff like that. It's usually a massive sheet, and then they have a laser cutter, and they're moving this thing around, and then kind of placing where the templates kind of match up best and kind of fit into the negative space, so that they reduce the amount of information that's been cut off, so that you don't lose the amount of leather that's potentially usable for other parts. So this part, you have to be as optimized as you can be without clipping through the other one and losing some of the leather for the other piece. So if you're doing it by hand, it's a little bit more work, but you can actually reduce the space of lost material much better than if you had to do it automatically. The computer does not know that you can actually rotate this and kind of squeeze it in next to that little piece and try to prevent the overlapping as much as possible. It's going to try and put things together as even more in a bounding box kind of way than it does manually having to kind of squeeze things around. So yeah, there's two different ways of approaching it. So the intent of the layout is kind of meant for you to think of this as a square. So that's your area that it will essentially be laid out in, and this is the bounds. You're not supposed to go out of the bounds of this square. So let's say the character's face would essentially be over here, then character's arms, one arm here, another arm there, maybe one leg would be there, another one would be there. So essentially you're trying to move these panels of the actual surface as a flattened version around until it fits best within that box. If you overlap like I have right there, just a few pixels, it will actually repeat that same bit of texture space to all sides, going this way and that way. Meaning if I overlap that, it's actually going to receive a small texture space on that side as well. So now let's say you have a character's eyeball over there, then suddenly the arm texture is now appearing on the eyeball. So you have to be within the bounds of that square. In certain situations, and that's much more advanced kind of topics, do you have the advantage of actually going out of bounds and actually start using more tiles for other parts of your model. But in generally, you want to kind of stay within the realms of your actual box. So that's essentially the layout part. Once you've got your layout, let me clear this out. And quickly write this out. It's there. So step 1, 2, 3, 4, 5. Step 5 would essentially be saving out a template. So create templates. And then this template is actually the representation of the final UVs. This template you would actually save out as a PNG file, as a JPEG file, whatever file choice that you prefer, and you can bring that into Photoshop that you can then go and paint on. Okay, so usually I put the actual template at the top and I create an empty layer at the bottom, and whatever I paint at the bottom will still show the actual wireframe at the top, so that you never paint beyond your borders of your actual UV template. Any part outside the UV template is essentially empty space or space that's lost. That's going back to that whole leather concept. Like if you have parts that's overlapping, then they're using the same piece of leather. And if they're not overlapping and there's a lot of material that's lost, that's essentially lost material. You can never recover that. Once it's cut, it's cut. There's no way to kind of get out of it. So those are the essential steps that you have to go through to eventually get to a point where you can actually texture your model. Once you've done that, then we're getting into the part of actually creating materials for your models that distinguishes between the different types of surfaces in real life. Like concrete has a roughness, glass has a smooth surface, wood, you get polished wood and you get rough wood, bark versus more kind of the wooden flooring or those kind of things, exactly, like these tabletops and so on. So there's different surface types, and each of them have different appearances and different surface properties that we can essentially mimic. So a texture that you've painted in Photoshop, it could be hand painted, or it could be something that's like a mashup of multiple photos that you kind of put together to kind of create a library of parts. And then whenever you apply that texture to the actual model, it will look like the photo or look like the hand painted textures. So there's different ways of essentially approaching that. You can go into the next phase of even taking your models into a sculpting software and then sculpting certain details. Again, let's take the example of like wooden planks. If it was a rough type of surface, I would probably try and look for textures that look quite rough, and then I would actually sculpt that onto the surface, and then I can extract that information as physical height relief and bring that in as a new texture map into Maya to generate a much more advanced kind of texture at the end of the day. The more textures you apply to the model, the more advanced the texture becomes, or the more advanced the actual material becomes. So the materials, just think of it as an empty book, and you can write in that book as much as you like to kind of create the story. So in this case, we're using, let's say, a wooden plank. That's our object. The object receives a material, and then that material could then receive a bump map. It could receive a diffuse map. It could receive a specular map. Different types of maps to essentially enhance the quality and the overall look of the design. That's the purpose. Okay, so we're going to go through this process using a simplified box. I'm going to go through that whole thing with you guys. So inside of Maya, what I want you guys to do for me is you're going to start off with a simplified box. You go to Polygon tab over here, and you can create your box right in the center of the world. And for the sake of this demonstration, I'm going to increase the polygon width, heights, and depth information under the input. So if you click on the polycube 1, you've got width, height, and depth. Just change all of them to about 200, and that's going to make a 2 meter by 2 meter by 2 meter box. So now that we have the box, we have to realize that every primitive that we start off with Maya actually comes off with its default UVs. Well, that's great. It makes our lives a lot easier, but as soon as I start doing extrudes or insert edge loops, any physical manipulation of the model by adding details, we're essentially changing the ways that the model is represented. Now, if you do that, your default UVs will not update accordingly. It would have been great if it auto unfolded itself and it did its best to kind of transform itself from a box to a character's face, but the computer's not that smart. So what we need to do is we essentially need to take our existing model and then delete the existing UVs and then start from scratch to build the actual UVs. Now, for the sake of this video, and for the actual class, I don't think I'm not going to use the default UVs. I want to start off from scratch so you guys have a full clear understanding of what the process involves, but I'm going to quickly show you guys what the UVs look like by default as a starting point. So let me open this up. I'm going to make sure I am in the modeling submenu set at the top, and then under the UVs tab or drop down menu, you're going to see the UV editor. So the UVs actually have multiple tools in it. In 2016, they've kind of localized everything all in one window, which is kind of great. So now you don't have to go to create UVs and then you have a separate UV palette for other tools. Now you have all in one go. So if I open up my UV editor and bring this into view, then you guys can see it's essentially like a flat 2D panel. Think of it as your working table. So if I zoom out, you can see this space is infinitely big. I can keep on zooming and zooming and zooming. This thing goes on forever. Now, which is great because then we can actually grab parts of the UVs and actually move them off the working space. And this is my area that I want to eventually lay it out in. I want to stack my UVs into this 0 to 1 space, not the others. The others, we can, there's some options to hide the other kind of 3 quadrants, but in my case, we're just going to kind of disregard it for now. So yeah, you end up with a default T shape, upside down T, and that's essentially our UVs for this box. So if I had to go right click and choose whichever component I want to work with, it's got the same kind of layout as your 3D view. So it's not suddenly a completely different set of tools and so on. You can't rotate, but you can zoom in and you can pan, but you can't rotate the actual UV editor in terms of camera movement. So if I go to face mode and I just click on one of these faces, it's going to select the borders, and then if I go to my 3D view, you can actually see the face that's been selected. So each face essentially represents itself in here as one of these blocks. Now if I had to go and deform the actual object, then the UVs essentially need to update accordingly. You can't have a box that now changes shape from a box to a trapezium and then your UVs are still perfectly square. They still need to adapt accordingly, otherwise you're trying to compress a UV that was initially square, and in ratio, in terms of physical model, it looks completely different in a 3-dimensional shape. So you have to consider those things as well. So just to kind of be very clear, one single vertex, every corner has a vertex, where the edges essentially meet. So for every vertex, there's one UV assigned in a UV space. So if I go and right click on the actual UV or the actual templates, and I choose UV, I can essentially do the same thing. The only difference is one is green, the other one is yellow. And UV space, you're selecting green dots. If you're trying to move those, it deforms the UV space, not the 3D space. Okay? If I change the 3D space, my UVs don't change. So they're linked directly, but they're manipulated independently. So you have to still go and change things. There is an option that you can go and toggle on to kind of keep the UV's ratio according to the actual 3D shape, but it ends up being more of a problematic thing if you want to move things around. It's essentially just trying to avoid stretching or compression. With that topic in mind, we also need to quickly address that in another document. So typical things that will occur on a UV or UV layout is compression, compress, stretch, and lastly would be to be facing the wrong direction. So let's say flipped surface direction. There we go. That's an N, by the way. Right. So those are the essential 3 things that would typically occur on your mesh, and we need to address them at all times. If you lay out the UVs and it suddenly changes from red to blue, you're either adding too much texture space or too little texture space. So red means it's compressed, meaning it's receiving less texture space than was initially assigned to the 3-dimensional surface. And then blue means it's assigned more texture space than the initial 3D surface. Flipped surface directions simply means that the object is pointing backwards and not forwards. So if I had, for instance, something that's meant to be pushing out, it's now going in. That's the only difference. So in certain situations you might want to have that effect. Typically in a gaming environment where you would actually map out half the face of a character. So let's say that's the character's eye with a nose over here and a big smile. Then they would actually divide the face exactly in half and then it's almost like folding a paper and then just putting the 2 halves together. So you end up with 2 eyes exactly on the same spot, the nose divided in half, the 2 ears aligned, and that means you're texturing one half and you're getting the other half for free because they're lying right on top of each other. So one has to face backwards, the other one has to face forwards. So that's just a optimized little cheat that they're using to, instead of having a much higher resolution texture, you're just using the same resolution texture, but you're optimizing it to only use half the texture space for the face. Okay, continuing with our little box, I want to get rid of my UVs. So the first thing that I want to do is I want to select my model, and then I want to go to my UVs, and then right inside here there's an option for deleting UVs under the edits. So that's the first thing I want you guys to quickly do for me. Just click that button. Right, so once we have the UVs deleted, I want you guys to also open up the UV editor for me. So just go to UVs and then right at the top, UV editor. Open that up for me. All good? So the next thing that I want to do is, now that I have the model selected, you can actually see my UV editor is empty. There's nothing in there. So we have to essentially select parts of the model that we want to assign as a flattened version into the UV space so that eventually we can then go and texture it. So we need to essentially do it to all 6 sides of this cube: front, back, top, bottom, left, and right. Okay. So the first concept that I want to introduce you guys to is essentially step 2 in our little step-by-step guide kind of thing, and that's UV mapping. So we're going to talk about the planar map at this point. So essentially the planar map is like, if you think about a regular projector, a projector is meant to do what? It's meant to take whatever we have on the screen and then sample that through a type of light. Let me create a new document and just quickly draw it out for the sake of the video. So there's our awesome projector, and here is our screen, right? So this image is being projected onto there, and whatever we display on the screen will essentially show on the projector, thus everyone can see. What if I were to take this screen and actually, just before we get to that concept, I want to just talk about this. So essentially, if I were to now move the projector down or up, what's going to happen with the projection on the image? It will essentially go off the bounds of our surface, the flat surface that it's meant to be projected on. So suddenly only part of the image is now projected onto the wall instead of the full image. So the same thing applies if we were to rotate it, right? If we were to rotate this projector, again we have the same issue. So the projector is very much constrained by the surface that we're projecting it on. If we wanted to rotate the projector, then either the surface has to update to kind of align it perfectly, so it's always perpendicular. So perpendicular meaning 90 degrees facing towards the actual surface. Okay, to have it perfect. If you don't have it perfect, it's not going to receive exactly the perfect image that we project from the projector to the wall. So the same thing applies to, you know, using UV mapping as a planar type. So going from here, if I were to now take this, you know, surface and I suddenly rotate it so it goes this way, what do you guys think is going to happen with this image being projected? You can see where it's intersecting over there, right? From there all the way to there, we're going to have stretching. Essentially, we're trying to wrap a piece or a certain set of pixels from that projector onto a length of a surface, thus appearing to kind of distort the image. We will only really notice it if we were to look at the surface on a direct head-on. But if you were looking at the point of view of the actual projector, it will look perfect because that's the image that's being projected, right? As soon as you rotate your camera, suddenly the whole thing kind of distorts and it goes all over the place. So that's essentially the same thing that's going to happen once we get into the UV mapping. So the concept goes like this. If I were to go to the UVs and then say planar, just hit that button and it applies a single planar map to the whole surface, to the whole object. Now what's wrong with this particular example? What's happening with the projector? The projector is currently aligning itself perfectly to the surface based on one of the properties that we have here. If we go into planar, you can see that by default it's set to Z. Or maybe not. Let's quickly do a reset settings and the default is X. So let's reselect that, hit apply, and you can now see it changed its little projector node to kind of align itself to the surface like that. So now from that point of view, it looks perfect. What about all the other sides? What about this? What about top? What about that? Will be fine because it's kind of projecting right through the surface. But bottom, left, right, top, all those sides would essentially be incorrect. Now let's see what that looks like if I were to apply one of these template textures. Can you see from this point of view it looks fine? Top, sides, horrible. So essentially the same set of pixels that's representing the bounds of our initial projector is now stretching fully along the length of the actual surface. So we're trying to prevent that as much as possible. So the only way we can do that is by, instead of projecting the whole object as an entire single planar map, you're breaking it up into multiple planar maps from multiple angles. One from the top, one from the bottom, one from the left, one from the right. Okay. So I'm going to undo this and I'm going to right click, face mode, select a single face that I want to project, like this one over here, and then I'm going to hit apply. And now we can see that all the other sides have no projection, no weird stretching, no weird compression, but from the side that we did the projection, that looks perfect. Okay, that's what I want you guys to do for me. Right, so I'll quickly want to address the issues that will typically occur, or things that you have to rather keep in mind as a default. It's not necessarily a broken mesh or an issue. It's more a case of, have to address those things ahead of time so you're always aware of it. So in my case, I made sure that I was looking down the x-axis of the model so that when I selected the face and I did the planar map, that it applies it in the right direction. So what do I mean by that? I'm going to point out a few things. So first of all, if we look at the model from more of like a three-quarter aspect, you can see that my x-axis is essentially pointing straight through the length of my character or my box. Right. So in this case, it was quite a simple approach. I selected the face. I went to UVs, and I applied the planar map with the options set to default being x-axis. No issue, no problem. So the other thing that I made sure of is in my UV editor, when I launched that, I make sure I click on the little checker preview button. So that will essentially just show you the texture on or off as a default. This is only a 2016 feature, so 2015 you have to go. I think 2015 might also have that. I'll just check at some point. But previous versions from 2014 downwards, I know for sure they just didn't have that feature. So you actually had to manually go and assign checker texture to your material, your Lambert or so on. So in this case, it's quite a nice little toggle on and off little thing for you to preview your textures. Continuing from this whole thing, if I were to, for some reason, select the backside. Now, this is typically something that I do. Everyone else does it. You don't even realize it. And then when you assign it, you realize, oh, my numbers or my letters are pointing the wrong direction. So when it's pointing the wrong direction, whether U1V1 is going backwards, it does not necessarily mean the surface is broken or anything like that. It means that the projector is pointing the wrong direction. So we have to physically take that, the projector, rotate it to the other wall, and it does what it's supposed to. So looking at our manipulator, I'm going to just temporarily turn off the display of the texture and quickly have a look at our manipulator. I'm going to pull it off to the side so it's easier for you guys to actually see what we are working with. So in terms of the projector, it's essentially a flat plane. It's meant to be a planar map. Okay, so the planar map fits itself to the bounds of the physical surface. So if we were to, let's say, non-proportionally scale the actual planar map or the planar projection, we can actually decide how we want the texture to kind of squeeze or be projected onto the surface. So if you select the outer bounds, you're just increasing and decreasing the actual boundaries of your planar map proportionately. And if you choose to manipulate these along the red and blue cubes on the outside, you're essentially squashing and stretching the UV planar map in a non-proportional manner. That's essentially what it means. So then along the inner sides of our little grid from our planar map, if you click on those, it's actually little lines that you can move around. That essentially represents how you want to move the actual planar map. And then last thing that is definitely worth mentioning is this at least one corner, and usually depends on which angle you're obviously looking at the model when you project it. It's meant to be in the bottom left, always in the bottom left corner of your projection. The reason being is that T represents the 0 point in your UV grid. Okay, so if we look at our UV editor, it essentially represents that corner right there. So if it was reversed the other way around, where it's pointing on the left or rather right hand side, essentially we instantly know that the projection would be the back facing the other direction. So in our case, if you look at this face being selected and this face being projected as a planar map, and you see the little T on that side, you instantly know that it is the wrong way around. Now, how do you fix it? If you want to fix that, there's quite a few ways of addressing that. You could potentially, probably the easiest thing would be going to the UV editor and then clicking on polygons and then flip. That will instantly rotate that particular panel, selected UV projection around. That's definitely the easiest way that I personally feel like you guys need to know. The second method is a little bit more advanced, and that is if you click on the little T in the corner, it's going to essentially open up additional options for this planar map projection. So if I click on that, it's giving us like a traditional transform manipulator, and then you can click on the circle, which will then give you rotational controls. And then you can rotate that exactly 180 degrees so that it is facing the right way around. So that's another way of approaching it. Multiple ways. If we actually have a look in our channel box, we can actually see that rotation happening here. Can you guys see there? It's currently 90, and if I rotate that around, you can see how that number changes. So I want to rotate it around until it is exactly minus 90 degrees, which will then be perfectly 180 degrees from 90 to minus 90. So that's a way that I typically kind of round off numbers to help myself, to get to like a perfect rounded off projection. In other cases, you can also make use of the attribute editor, and then you can see there the same attribute again applies itself in the first first tab. You have rotate X, rotate Y, and rotate Z. And which one are we rotating? We're essentially rotating the middle one. If you change that, you can see that the middle one is changing. So there's multiple ways of approaching this. The easiest way being just going to UV editor and then clicking on flip, and that's going to rotate that particular panel. So another useful tip that I always tell people to make use of is actually turning on the ability to see whether something is facing the wrong way around or not just by looking at the actual preview texture under the UV editor. So obviously if you turn that on and you can see the numbers are reversing the wrong way, then you would instantly know that's not right. But let's say you have a model that has 10,000 faces and you have to go through each of those. It's just literally impossible. You can't really be using that kind of method. So another way would be to actually preview the shell to be shaded. In Maya, when you go turn on wireframe, you press 4 and you press 5 to go to shade it. You've got essentially the same thing in the UV editor. So if you go under the I'm not too sure where you turn it on in the menus. I hardly ever use that. There we go, shade UVs. Another way would be just pressing that button that looks like a blue cube with a white outline at the bottom. If you click that, you'll now see that the shell turns red. Okay, so if I move this off, you can actually see that's red. So when it's red, it simply means that it is the back way around. You just need to flip it. So just by going to polygons and clicking on flip, that will automatically rotate our panel. Now it's blue, so blue is the color that we want, and we are happy with that. We don't need to change anything else in terms of actual rotations or all that manual setup that we initially had in the viewports. If we now look at, if we were to line this up back to the U1V1 panel and minimize this, we can see now the numbers are pointing the right way around without any issues. Okay, so what I want you guys to do for me, if your faces are pointing the wrong way around or the numbers are reversed, just select that face or the UV panel itself and then quickly go to the UV editor and then clicking on polygons and then flip. That should fix the problem for us. To make it easier for you guys to actually see whether something is flipped or not, it's probably better to actually toggle off your grid or check your texture preview, and that's going to show a solid blue or red color. If they're stacked on top of each other, which will most likely occur once you have multiple projections, then it's going to start changing to more of a weird purplish mixed color between the red and the blue. That instantly gives you a clue that they're stacked on top of each other. So every time you create a planar map, you want to check if it's red or blue. If it's right, good. Then instantly move it off. Go and click on the middle circle, just move it off. And if I go back to my model, and let's actually move my UV panel off screen, grab one of the other sides, like this side, and I go to create UVs, planar, option box. This time I'm going to switch from X to which direction? Z. I'm going to click on Z, hit apply, and now we can see it moved it right to the center in my UV editor, exactly to the center box. I'm going to click and drag. I can instantly see it's red. I go polygons and I say flip. So that's going to be my process for every face, meaning 6 sides that you want to repeat this process for. I'm going to give you guys some time to do that. So I'm going to quickly spend a bit of time just laying out the UVs, or mapping out the UVs for all the other sides. I'm going to select the top and the bottom this time, so you can do multiple projections if you want. So you don't you don't necessarily have to do one at a time. Okay, it just makes your life easier in terms of quickly blocking out everything. But the only issue is they will overlap, so then you have to kind of separate them off. So I'm going to show you guys how you would do that in this kind of situation. So with the top and the bottom selected, I'm going to go to my planar map options, and this time I'm going to set it to do a Y projection, so going from top to bottom or bottom to top. It doesn't really matter. One will always be reversed and the other one will always be upright. So you have to go and take the reversed one and just flip it around. So I'm going to go to my UVs, planar map option box, Y axes, and hit apply. So once I have done that, you can actually see the projector is facing straight down. And from the top point of view, you can see the little T is on the left-hand side, which is great, meaning one of the sides are pointing the right way, but the other one is kind of a bit off. So if I were to move the actual handle in the UV editor, both of them will move together. So we need to first separate the one from the other. So the way to do that is by turning on the shell selection tool. Currently, it is set to select whatever was projected initially. So I want to essentially go out of that and just click on the select shell button. And you can do that through many ways. I think there is a particular button under the selection, and then select shell. Okay, that's one way. The other way is by clicking this button. I think it's the second button, move UV shell tool. So if you click on that, then we can actually click on a single face. Do not click and drag. If you click and drag, you're going to select the whatever is below it as well. So if you have multiple things on top of each other, when you do a click and drag, it does a ray select through everything. So by clicking, single click on the actual UV panel, it will then be able to separate from the bottom half. Now you can see one of them, probably the one at the bottom, used to be, that's kind of the flipped one. So I'm going to click on that. It's going to select the shell, polygons, and then flip. Reverses it, and now we have 6 sides successfully laid out. 1, 2, 3, 4, 5, we miss one. So we probably need to do one of the other sides. I close this, select the shell, move it off to the side, so we know this is top and bottom. And this one over here is the side. This one over here is the other side. This one is over there. So we need to probably just turn on the texture, it's much easier to see. It's going to be this one. I'm going to click on it, have it selected, and so let's quickly have a look at our level manipulator. That's pointing along the Z axis. I'm going to have that selected. Panels, UV, planar, set it to Z, and apply. Awesome. Turn that grid texture off and move this to the side. You can see they're all blue. Great stuff. I'm happy. Most of my work is pretty much done. The last few steps that we need to go through is now sewing and moving. So if we go back to our Photoshop documents, quickly have a look here. So we created the object, we did the UV mapping using the different planar maps for each side. We didn't talk about the cylindrical. I'll quickly cover them just to give you guys a general idea of what it's about. We started moving them, but we haven't sewed them actually together to make one single panel out of it. And then last, we need to lay it out and then create a template to send to Photoshop. So let's quickly address the cylinders, the spherical mapping, and the automatic mapping. So for a simple object like this, for instance, I'm going to make a duplicate and then hide the original. And then we can delete the UVs for this one. Polygons, and then delete UVs. And I'm going to quickly do an automatic mapping on this one. If I go to UVs, there is a automatic mapping, and usually the default option for the automatic mapping is set to 6 planar maps. So if I open up the option box, you can see it's set to 6 planes. Very bad. In this case, obviously, there's only well, 6 would actually work perfectly fine because there are 6 sides to this box. But you have many options. You've got 3, you've got 4, and you've got 8, and so on and so forth. In fact, I'm going to set mine to 4, so it does 1 from the top, 1 from the bottom, 1 from the left, and 1 from the right, just so that you guys can get a general idea of what it's intended to do. I'm going to hit apply, and now it generates 4 sides, but it did one of them at an oblique angle, actually 2 of them. In fact, 3 of them, and then 1 being straight. So it's not aware that it's meant to be perfectly planar. This is more for when it's trying to capture all possible angles for more like a rounded surface, like a character's face. You know, in that case, it's going to try and break it up into multiple parts where they overlap, and then you have multiple parts that you have to go and stitch together. So that's, in some cases, it's good. In other cases, it's actually very annoying. So if I set this back to 6 and then hit apply again, now it's doing it top, bottom, side, other side, back, and front. That seems to be a pretty good projection. And guess what? It laid them out for us in the right direction, which is awesome, but they're not all nicely spaced out so that we can go and stitch them later. But it does a good job for a simple box. Now, a box with bevels would not be going so well. In that case, it actually does a pretty crappy job, so we wouldn't really be relying on the automatic mapping. So in certain situations you want to use that, in other situations it's kind of just a waste of time because it gives you more work to go and clean up afterwards. But in this simplified example, this works pretty well. So I'm going to create, just delete this guy for now. I'm going to create a cylinder, and on the cylinder I'm going to quickly delete the UVs. UVs delete, and then in this case a simple cylinder map would suffice. So doing pretty much the same thing, but it's just like a planar map wrapped around the object. Unfortunately for us, we do not have a custom shape map type. You can't go and change the projector to suddenly transform into this character's face. So you're very limited in the types of maps that you can project. You can either do a plane, you can either do spherical, cylindrical, or automatic mapping. There is one extra one, it's a camera-based projection. That's again more of an advanced kind of technique where you only want to project it from the camera's point of view. But it's quite useful in certain situations. So that's essentially what you will be using in a simplified state. If you were to do it like a wine glass, the cylindrical map will do a good job as a starting point, but then you still have to go and process it a little bit to get it to more optimized UV layouts. Spherical, obviously anything that's spherical, like a rugby ball, going from soccer ball, anything spherical, character's eyeball, you can do it using that. So just kind of addressing those as it is. Bring back our original box. We're now going to address the moving and sewing. So if we look at this, we can see there's 2, 3, 4, 5, and 6. So we need to stitch these guys together as if they're originally laid out in a way that they were kind of already sewn together. So how can we do this? I'm going to use this example. I don't know how many of you have tried this in the past. If you take a box and like an actual, or let's rather put it this way, if you take a piece of paper and you cut out the actual pattern and you fold the parts together and you glue them together to make the little box. So we need to essentially do the exact same thing. You need to lay it out in a way that you can actually eventually have the full three-dimensional shape, but as a flattened version. If you leave them as separate panels, that should not break anything, but for the most part you want to try and put parts that belong together without needing to kind of look for it. For instance, you don't want to have the hand unsewn from the wrist, from the rest of the arm. You actually want to have that as part of the same thing. Some cases you might have variations where you do want to have the hands completely separate from the arms, but you just want to put parts together that belongs together for the most part. Okay, cool. So how do we do this? How do we sew these things together? How do we put this onto that and then merge it, essentially like what we do with a target weld? Well, it's not as easy as you would believe with just putting them close together and selecting the 2 points and say move and sew. But in certain situations, it's actually very easy. I'm going to show you guys the easiest way, and then I'm also going to show you the hard way. I think it's benefit to understand the hard way more than it is to just click a button, yay, it's done, kind of automated process. So to do it manually, I'm going to go and right click on my actual UV object or my UV shell. These panels are either called panels, they're called templates, they're called shells. So whatever I refer to it, just know that I'm essentially referring to the shell or the shaded part of the actual UV piece. In this case, it might be a single face. So if I were to right click on this and go to edge mode, I can actually select a single edge. Okay, if I select that edge, what will happen in my UV editor, it will automatically go and select the corresponding edge from the other side. Now it's a bit difficult in this particular background being gray and the color being so obscure, you can't really figure out whether it's actually selected or not. Just know that it's when the edge is selected, it's orange. We can go and change that. I'll show you guys a little bit later. But when you have one single edge selected, it will try and select the corresponding edge on one of the other UV shells as well. So you're not going to get confused in terms of which part essentially belongs. On the 3D model, if I were to select a single edge in my UV editor and then preview, or rather show you guys what it looks like over here, can you guys see that this edge shares this face as well as this face? When we did the planar map, we projected the top side and the bottom side separately, meaning that they're not physically sewn together, but they still share the same edge. So that edge is now divided into two separate halves. Thus, that's why there's two edges. It's the same edge, but it's just represented into two halves from each UV shell. Just want to make that very clear, as many people actually get confused in terms of which part belongs to where and why is there two edges in the UV editor, but it's not the same in the 3D surface. So having that edge selected, I can then go and say, open up the polygons, and then down here at the bottom there is an option for sewing UV edges. Now, Maya is smart enough to know if this is one edge and that's another edge, they will sew it together, but it's going to do something very interesting. Enjoy. It will try and pull the edges from wherever they are in 3D on the UV space and pull them together and breaking the whole thing. So that's not what we want. We want to have one UV panel actually move itself, rotate itself, align itself, and then sew the edges that's right on top of each other. So the manual way would be to actually selecting the shell, moving it down, rotating so that the two halves are pointing towards each other, lining it up, and then manually sewing the edges. That's the manual way. So now you can appreciate why it's so much work to lay out the UVs if you had to do it the traditional way. So with that selected, I'm now going to go to polygons and then say move and sew this time. Just one below that. If you click on that button, it will automatically take the whole shell, rotate it, move it, align it into place, and then sew it to the one where it's supposed to be attached to. What's nice about this is if I now turn on my actual texture grid, you can now see that the texture is now wrapping around the corners automatically. Meaning if I were to grab that UV shell, clicking on this move UV shell button, clicking on a single one, it will now select the whole shell, and then when I move it, both halves are now moving together instead of just the one original half. So what I want you guys to do for me is you need to essentially sew as much as you can together and kind of create that initial T shape that we originally had. Okay. So now that we have the actual UVs laid out for this piece, if I were to, let's quickly turn on the texture preview, we can actually see that they're now encompassing at least 3 tiles per UV shell. And we need to bring this back into our initial grid. So you can do this manually, And what I recommend, if you were to do them manually, you have to try and keep the ratio of one UV shell relative to another. You can't go and change one bigger to use a less texture space versus another one using more. Initially, the 3D model, all sides equal the same. So you can't go and, you can if you want to, if you don't need to have as much resolution at the back. But if you're going to see the actual object from multiple angles, it's always going to be best to actually have, you know, even ratio across the surface. So if we were to quickly take this and then select all panels, in this case just 2, and then move them across to the center of the grid. And just for the sake of, you know, seeing the grid underneath, I'm going to turn off the texture. So I'm going to take this and I'm going to jump to my scale tool, and I'm going to bring this down and then scale it and fit it using my move tool more or less within that space. And you can try and scale it up until it just about hits the borders. You don't want to overextend it. As soon as you go over the edges, it will now start repeating whatever you have on this side with whatever you have on this side. So be careful. You always want to stay within your bounds. Okay? It's a bit of a... You can try and really get close and then scale it up until you have as much of the texture space used. But then we bring in one extra little element, and that's called bleeding edges. Now, if you're familiar with some of the typography kind of stuff, there's always going to be a bleeding line, or I can't remember the exact term. I think it's called bleeding edge or bleeding line. It's essentially how much the pixels will bleed in the ink once it's been printed on the paper. You always want to have some leeway so that the text do not touch each other and then suddenly they're kind of, you know, blending into one single word or letter or whatever. So we usually, depending on the resolution that you bake your textures out or kind of paint, you're going to start off with 1 pixel of edge space between the UV panels, being from UV panel to UV border or UV panel to UV panel. So we can actually get these two much closer in terms of that, to make use of that same theory. So if I put these right on top of each other, then if I were to go and texture this, it will always apply a single pixel bleed, and then you're just blending right across to the other UV panel, thus you're getting pixels from one side to another, and usually you don't want that. Especially when you're doing baking, when you're baking out your textures like normal maps and bump maps and those kind of things from other surfaces, you end up having some additional pixels over the edges. So that would be a general really good layout in terms of, you know, hand placing or hand moving the actual UV shells. If you wanted to do this more of an automated way, you would actually do this using the polygons, and then under the layout there's an option box. So I'm going to open that up, and the default settings usually is good enough for the most part. There's a few things that we can address. So if I hit apply, it will automatically rotate, and it's going to try and compensate for that single pixel edge percentage and stack them as close as possible to the UV borders and scaling them proportionately to each other and to the actual UV shell, or rather to the UV grid. So that's quite nice. If you don't want them to rotate, let's say you were very specifically laying out them in a horizontal method, then if I quickly undo this, there is an option under the UV layouts over here to not rotate them at all. So if I leave them to none and I hit apply, it's only going to position them and then scale them accordingly to fit within bounds. So that's a nice option. It's, let's say you had a wall, and that wall was laid out in a horizontal fashion so that when you apply the bricks, that you don't have to physically go and rotate the brick texture in Photoshop. This is a typical solution where you would then just turn off the rotate, so it stacks them in a perfect horizontal layout. There are some other options, like if you want to pre-scale the actual object relative to another object or relative to all the objects in the actual world. So there's options like that. There's also options to scale them proportionately or non-proportionately if you want them to maintain a certain shape and you don't want them to be compressed to cause stretching or compression, then you would typically go and address those options under the scale. So uniform, leave that, it's perfectly fine. That just maintains the actual proportions and the layout as they are in here, and not going and stretching them to fit the actual borders. So instead of scaling them to fit the borders on a non-proportionate way, it will actually take the whole thing and scale everything up uniformly. So that's what that feature does over there. If you say stretch to region, if you had it kind of, let's say it was laid out in a way where it was like that, if you click on stretch to region, it will literally kind of stretch things, and you don't want that. Right, so, and then lastly, the spacing, or the shell spacing. This is quite important for optimizing it for different resolutions. The default setting is set to 512 pixels by 512, being from 0 to 1 in the corner to over there, and 0 to 1 to there. So by changing this to 1K, we're essentially optimizing it so that all the UV panels are now optimized to fit a 1K texture, meaning it's compensating the actual spatial difference between one shell and another, and a one shell between the UV borders, or the actual texture border, to compensate whether it's 20%, 2%, 0%, you know, whatever you choose at the end of the day. So that's also a nice option. Once you've done that, you're pretty much ready to then export this as a template to bring it into Photoshop. So I'm going to quickly give you guys a few moments to quickly, you know, place them within the 0 to 1 space, and then we can get into actually bringing that into Photoshop. So the next part is for us to take our existing UVs that we've just laid out. Quickly want to change a few things in here just to reset my settings and hit apply. Doesn't really matter in this case whether they're upright or not. It's more of a situation when you have a very specific object that needs to be, you know, upright or, you know, to the side and so on. So once I have laid those UVs out and they're fitting into the 0 to 1 space, then we can actually go and save out the UV template. Now, you can go and save out the UV templates and bring that into Photoshop, or you can actually use that directly in Maya and paint onto a 3D surface. Now, the painting tools in Maya are essentially very primitive. They're not designed to actually work, you know, like a proper painting tool. It is good enough to give you a basis to start off with, but it's for the most part only used in very particular situations, or at least that's how I use it. In the beginning, when it was like the coolest feature when it came out, you would typically use that to kind of, you know, paint your diffuse map, paint your specular maps, your bump maps, and all those kind of things. Now we tend to use a more advanced tool like Photoshop that gives you more, you know, access to different functions and so on. So I'm going to show you guys the Photoshop method for now. So under the polygons, if we go to polygons, we can actually go to the UV snapshot all the way at the bottom. And what's important is you have to realize if you don't have a project set, this will probably randomly save to the default location or the default project that's set off in your documents. So if I click on UV snapshot, it's going to open up the UV snapshot window where you choose where you want to save this out. And you can see in this case, my last project that I set it to was the house project. So if I save this, it will go and save this UV snapshot in the images folder. This is how Maya will automatically save things to a project. So it's probably a good idea to always make sure that you save or set it to a specific project so that you don't go and have to look for it. In my case, I'm just going to save that template to the desktop and then call that my UV box. And then we can see that goes straight to my desktop, and the current default resolution is 256 pixels by 256 pixels. So as soon as I change this to, let's say, 1024 by 1024 by pressing tab, it automatically fills in the one at the top. Why? Because it has the keep ratio button checked. If you want to change the ratio, usually you don't want to do that, then you could do that by just unchecking that. So then you have the option to color or fill the actual wireframe with a specific color. I'm going to leave all that stuff default. You don't need to worry too much about it. The only other thing that I typically change is changing the default format from IFF, that's the photo or the Maya default image, image formats, if I can call it that. And use something that Photoshop understands, like PNG, TIFF, Targa, those kind of file formats. If you save it as a JPEG, you will actually bake out the transparency as a flat. Then you don't have the ability to separate the background from the actual transparency of the pixel that's been painted. So that's the reason why I choose PNG. Okay, PNG stores alpha information. If you guys haven't worked with alpha, or masks in Photoshop, this would probably be a foreign concept to you, but in general, just know that you actually have a way of like creating a cookie cutter, like an effect where you can take out something that's behind something else by masking it out. So what I'm going to do next is just hit OK, and that will now save out the image saved to desktop uvbox.png. So what I'm going to do now is leave Maya alone for a bit and then quickly jump to Photoshop and then open up that Photoshop template as we've done just now. So I'm going to go desktop and scroll down to my UV box, if I can find it. There it is, open. And that's going to load up with that UV layout with the transparency. So if we look at over here, we can actually see it's got layer 0 and it doesn't lock it to a background. So we can now go and create another layer, let's say below that, just move this layer 1 below layer 0. And for the sake of keeping this simple, I'm going to call the layer 1 background, and layer 0 I'm going to call it UV, so that we know which one is which. If I were to fill the background with a color, I'm not sure if you guys are familiar with the actual hotkeys. Shift backspace will open up the fill options, and then you can choose to fill it with black. And hit apply or OK, and that's going to fill that background with that particular color. And then finally, if I want to toggle the visibility on for the UVs, I just click that on and off. Right. So the last step for me, just to kind of preview this for the sake of bringing this back into Maya and actually see what we're working with. In fact, let's do this. I'm going to save it out as a template, connect it into Maya, show you guys that whole workflow, and then whenever we paint on the mesh or on this actual UV template and just hit Control S to save, it will instantly update and go straight to Maya. So there's a live connection then, which is great. So I'm going to go File, Save, and I'm going to call this guy, just for now, make it a JPEG, and I'm going to call this my diffuse box diffuse. Let's do that. Box diffuse. Yes, full quality, hit OK, and there we go. So back to Maya, and I'll go a little bit slower next time. I'll show you guys just now. You're going to then select your actual objects. You're going to go right click, and you're going to create a brand new material. So the default material that's assigned, you never assign your textures to that. You always create a new material. It will become more apparent in the next lesson when we start getting into like hectic details and so on. So I'm going to go new material, and then it's going to pop up with a assign new material window, and then we can choose one of the materials that is provided by Maya. I'm going to use a Lambert in this case. I'm going to click on Lambert's. That assigns the Lambert to the object, and it goes to the attribute editor. You can see Lambert 2, that's the second one, and then we can load in the texture under the color slot. So I'm going to click on that little checker box, input connection. That's going to open up additional window again, and we will then link in a file or JPEG image into this. I'm going to kind of direct Maya to where I want to load the image from. In this case, it's going to be on the desktop, if I remember where I saved it. Save as, that goes to the desktop. Some JPEG, I'm sure I saved it here. Yes, box diffuse, that is the one. Let's do box. There it is. Open it, And once you open the box, we need to turn on texture preview. So you have to press 6 on the keyboard to preview the texture. You see that the edges for the UV borders are now exactly on the same edges of the actual model. It's filled with black. It's connected with Photoshop. So any changes that I do now will then instantly reflect as soon as I obviously draw this paint with red. I'm going to type in or write 1, 2, 3, 4, 5, and 6. I'm going to hit Control S, save it out. I'm going to choose my JPEG. Box diffuse, save. I would like to replace yes, yes. And then the last thing in Maya, all you have to do is literally just click on the sample icon here at the top. And that's going to refresh and then bring back the texture into Maya. Okay, so that's essentially what we want to do.